We are Group 35. Because of these characteristics of the game, we have adopted the following three techniques.
YINSH game integrated rules from Othello and 5 in a row. In order to win each match, it requires 3 times to form 5 counters in a row. Since the YINSH game board is not regular square, we need to map each point on the board to a 2-dimensional array along with some extra walls, which in the array represented by 5. So it would be much easier for each algorithm to implement it and run on the board. The action of the game are the collection of all possible moves of the rings on the board. The possible expanding directions are vertical, horizontal, and diagonal directions. The following diagram shows a scenario for a random match, which different models can be assigned to an offensive and defensive position, which are represented by the green and the purple respectively. For offensive position players, the rings are mapped to the 1 and the counters are mapped to the 2. Defensive position players, on the other hand, are mapped to the 3 and 4. Temporal difference reinforcement learning includes off-policy method, Q-learning, and on-policy method, etc. Since Q-learning guarantees the result is optimal, so we want to use that as a policy for a project. In the YINSH game, the primary challenge we are facing to is the limitation of space complexity. It's not possible to simulate all cases on the board with a limited memory space, so that we use the method that approximate the maximum value of Q to the approximate Q function, which is the sum of the features times their weights. The final version of our model in the tournaments implements 6 features, which are the 6 strategies in our game. First and the second represents the score from our player and our enemy. For the third and the fourth features, we created those 2 features represents the number of counters of our side and the opposite side. Thus, the 5th features indicates the minimum moves required to move to the 5 counters in a row. For the 6th feature, which is the block feature, tells the minimum moves our enemy can take before taking a ring out of the board.
We choose A star since it's simple and classic. There is already a good implementation in the previous assignment and tutorial. The core of this problem is to generate an appropriate heuristic function in a short time, since A star is sensitive to H values. We are using a 2-step reduction. We just think about forming 1 sequence instead of 3. Then, we can just greedy consider the 5 areas that is nearest to forming a sequence through the whole map. Finally, we just need to consider all the combinations and patterns of 5 blocks. After calculating all the possible combinations of H value for both players, we store the list into a JSON file for future use. The outcome shows that A star is relatively efficient compared to brute force search and Monte Carlo tree, but there is little space to improve due to the limitation of time complexity, and we cannot consider the potential action of the other player.
Monte Carlo tree search is a tree data structure-based search algorithm that can weigh exploration and exploitation, and is still relatively effective in a large search space. This tree search algorithm consists of 4 main stages: selection, expansion, simulation, and backpropagation. We use the epsilon gradient algorithm to make a compromise between exploration and exploitation. If we had more time, we might try AlphaZero to improve performance by gaining experience through self-gaming. In addition, MCT search is online planning, which has some disadvantages compared to offline planning. At first, we used deep copy, but later we found that deep copy would increase the complexity of storage operations. In order to improve the speed, we use Pico module.
One of the advantages of Q-learning model is that it's extremely fast. As you can see in the video, it can only take 0.01 second to select the action. The other advantage of Q-learning model is that it can use features to form 5 counters or block enemies' counters, like scenario in the video. The most significant disadvantage of our reinforcement learning is that it didn't implement it with strategies that guarantees a win. It always chooses the better action based on the features it has, but those actions won't always win.